This is Dean Phillips. I am your host today for the Longevity Industries presentation of the Destiny of Manufacturing podcast. Our sponsor today is the Precision Metal Forming Association and the PMA's Educational Foundation. I am honored to have co-founder of Hybrid Manufacturing Technologies, Pete Coates. Pete, how are you doing today?
I'm doing great, thanks, Dean.
I appreciate you taking time today to be here on our podcast. And if you wouldn't mind, can you give a little introduction to your background and to the history of hybrid manufacturing?
Yeah, sure. My background began in the late 70s, building traditional machine tools with Cincinnati Millicron. That evolved into the testing and assembly of CNC machines, and then ultimately into the service and retrofit of newer equipment to older technology, and ultimately to join with Jason Jones, my co-founder, to set up and launch hybrid manufacturing technologies.
Excellent. And we did have Jason on a previous podcast, and we do appreciate you guys being on here. Jason gave us a little bit of a background. Tell us a little bit about how you came to move from CNC, or at that time NC, into this new world of additive.
Okay, it's an interesting story, Dean. My first introduction to additive manufacturing was during a visit to a university in the UK. Jason was at the university, and they, together with the professor there, were working with additive technology, and in particular in the rapid prototyping market. I delivered a machine tool to them, and were in the process of training them to use the machine tool. And they asked me if there was any way that we could integrate the additive technology into the CNC platform. That was my first introduction to additive. At that point, this is back in 2007, 2008, I had no exposure at all to additive. The guys showed me what they were doing, explained some of the technology, and to be honest, at the time I was skeptical, very skeptical. My background had always been in subtractive. We'd worked for many, many years developing machine tools, developing cutting strategies, particular high-performance machining, where the goal is to remove all of the heat out of the machine and take a component off very accurately, produce very accurately, very tight tolerance. And here's a couple of guys that were talking about melting metals inside of the machine tool. So, yes, initially I was very skeptical. And they took a little bit of convincing, took a little time to convince me that this was something that we really wanted to do. But as the project progressed and I was exposed to more and more of the additive technology, it became clear that this really was the way that the manufacturing would move forward.
Yeah, and move forward it has at breakneck speeds. It's really taken off, and I think as we take, part of the destiny of manufacturing is we take a forward look of where we're going in things. With your background in CNC, how has this changed materials-wise to where we are now and where we will be in the future? As far as I know, that a lot of people always talk about one of the limitations is the materials. How do you think that's has evolved to where we are now and where we will be in the future?
I think the additive has brought the ability to mix materials in the same components. For me, currently, that's the really interesting part of this whole project. Traditionally, we've taken a piece of material, whether it be steel or aluminium or whatever it is, and removed great pieces of it to produce a shape. And that shape's generally been limited by the ability of the machine tool to produce that contour. And that ability has improved significantly with the introduction of 5-axis CNC and CAD-CAM, etc. Moving forward from that and building on that complexity of the external geometry, the ability now to add multiple materials and build single components out of many materials is extremely exciting. And I think that's where this technology will lead us. It will, over time, give us the ability to produce components that are fully optimized, both from a shape, geometry standpoint, and also from a material to enhance and improve that particular component or the performance of that component. Which leads obviously to reducing mass, reducing weight, adding more functional capability, and all the advantages that comes with that.
Right. It's interesting that you say that because talking about shapes and things like that, I've been on a couple of conference calls and seminars talking about how the rolling materials, the rolling industry, and the production of flat rolled steel has changed. That in the old days, if you wanted thicker material, they would just add a rib, or to reinforce an area, they would weld on a certain spot. But now what they've done is they've actually brought that into the rolling process, where they actually roll the material thinner in certain areas and thicker in other areas, and it reduces the secondary processes and also allows them to do different things within the materials that hadn't been done before. And is that a challenge that you see from a machining standpoint when you have these weird or intricate profiles of a part, to where it because basically nowadays with additive, the actual part can be formed in all different shapes and geometries, such that it in many cases probably is more of a machinist nightmare. Is that a challenge on the tool?
Yeah, I think we talked about the several families of additive, and one of those families is clearly powder bed, where your geometrical freedom is really almost your imagination. However, you still need to, in many cases, finish that component somehow on a machine tool or some other post-process. Designing the ultimate shape from an aesthetic or from a strength or from a weight perspective is great, but you still need to be able to hold it somehow. And that is the challenge with those particular technologies, is that you still need to hold the thing to do any post-operative machining. The hybrid approach that we have developed is slightly different to that, in that we work off a substrate, and that substrate could be a piece of raw material, it could be an existing component or an existing forging, and that gives you the ability to take something that is relatively easy to hold and build features on it in a single setup, so that you don't have the issues around fixturing that you would have with a true powder bed produced component, for example. But certainly some of these new freeform shapes do add an awful lot of complexity to the machining process.
Is when you get into machining these components and holding them, it's I can only imagine some of the people, like you said, like yourself, initially being somewhat skeptical. Do you find that to be a challenge from a workforce standpoint? To training the people is a huge part of the actual process of bringing in a piece of equipment. Is the learning curve for the individuals, and is there things that you feel that we can do over the next 5 years to reduce that fear or skepticism and reduce the training time?
Yeah, I think the problem that I've seen over my career in machine tools and in CNC production is even a change in the control technology is usually meets some resistance. Typically, I was involved with a number of very high-end, very advanced CNC machine tool builders, and they would bring a control out that sort of changed the way the CNC was used. And it would always come again, there would always be some resistance to that change. And I see that now. I see a lot of skepticism in parts that have been produced by an additive process. But I also see a lot of people that are coming through that have now been exposed to 3D printing in schools, for example, where they're using plastics and other materials to produce shapes. Those people that are now being exposed to this sort of technology are starting to appear in universities and other places where they will be the designers of the future and they will be the machine tool operators of the future. And that resistance is not there. They see this as an interesting challenge. And moving away from traditional manufacture where you take a piece of material that is as big as it needs to be and remove 90% of it is clearly unsustainable. And I think people that are moving into manufacturing today understand that and understand those challenges and are prepared to embrace it. And it is exciting.
Yeah, I think right now in manufacturing, this is one of the most exciting fields and really inventive areas that it gives you this ability to create things, to create parts, to it kind of, if you can dream it, you can build it kind of additive or ideas rather. And have you seen that the new people coming in have almost a less fear, I guess is the way to put it, that, when you've been in the field and you know that, well, we can't do these kinds of things because the materials or because of you don't have enough thickness there to support things, that out of that, let's say ignorance or lack of knowledge has kind of spawned a new creativity that somebody says, well, okay, you say I can't do that, but I can come up with a new way to produce this part that was not even, it couldn't even be envisioned because of the limitations of machining and the limitations of welding or manufacturing. Do you see a new creativity coming out of this?
Yes and no. I think in a lot of the traditional industries, and I'll put aerospace into that at the moment as well, they realize that this is the route they have to take for the obvious reasons. But a lot of the designers and all the people who have to sign off on this stuff are still nervous because they don't understand, and I don't think anybody understands fully, the properties of this type of component. For many years, we've developed many processes and products and proven that they work by manufacturing them using traditional techniques. A new technique has come along with additive manufacturing, and getting these designers and engineers to adopt these new technologies and take this risk of using something that they don't fully understand is difficult. And I think that is stifling the creativity to a certain extent at that level. That being said, I think at other levels with non-critical parts and other areas, that yes, creativity is definitely, people can conceive of an idea, they can program it using CAD, they can produce a CAM program, and they now have the tools to produce that quickly and see what they've imagined and hold it and feel it and use it. And that, I think, it really does spark the imagination. So I believe that as people come through university and the younger generation of production engineers come through, that they will embrace this technology fully, and we will see some huge leaps in the design and the use and the popularity of this type of part.
Sure. In the areas of education, what are some of the things that you think that over the next 5 years we need to be doing in our training worldwide to prepare people for the changes that are coming? Is it more on the materials side, or on, we haven't even touched on developing curriculums around additive manufacturing within traditional engineering. Most schools have programs, but they're not specific to additive technology and learning the limitations of how materials are applied in this way at most schools. Do you think that that's an area that we have to shift from?
I think it's more fundamental than that. I think my experience is that many schools and education facilities, there's a huge disconnect between products and how products are made. People come out of education without an understanding of manufacturing. I think that in the West we've done a really good job of putting manufacturing in a box and making it not such an attractive industry to go into. And I think there is a huge disconnect there. So I think there needs to be a complete rethink of how we approach training and bring these young people through, expose them to industry and really show them how things are made. And it's a very, it's a career that is extremely exciting and extremely rewarding. And I think, unfortunately, a lot of people miss out on that because they're not exposed to it at that age or at that point. So we are in a position where we need to do something with education to, first of all, re-engage young people with production and with manufacturing, and then expose them to the really interesting technologies that are now starting to emerge, which will allow us to produce these really exciting and powerful components.
Right. There was a time, I think, that we really got away from, where vocational schools and technical schools were far, at least in my eyes, there were so many more of them. I went to a vocational high school, and which is now, I think, what they call a math magnet school. And it's a shame to see that, because I was exposed to a lot of different technologies. I took classes in refrigeration. I took them in electronics. I took them in computers. I took them in machining. And by being exposed to all these different technologies, kind of formed at least a basic knowledge of what was possible and what could be done. Even if it was limited, you at least knew and weren't afraid to do it, and you felt like you could get involved in that. And do you think that manufacturers can get involved with the educational system to try and excite the students about that, to show them that this isn't what maybe some other people have told you manufacturing was? Do you think there's more of an obligation to kind of do that?
Absolutely, and I think it's a necessity. Without educating the young people, then where do we go in the future? When this current group of people that work in production and design are looking to retire, who replaces them? So absolutely, we need to do something. Yeah. And I think I know when I was at school, for example, that many of the teachers, particularly in the technologies, metalwork, woodwork, technical drawing, that sort of thing, were people from industry.
Right.
And I think we've gotten to a point now where it's almost everybody should be an academic, and that clearly that's not the case. We need people that make and do. And I think teachers and others, educational professionals, tend to go to school, go to university, go back to school again. And I think what we really should do is open the schools up to people that have been in industry that can bring that experience, that passion, and that excitement back to the classroom, and really infuse our young people to get into these careers.
I think that's a great approach, because when I was in school, that was what really kind of inspired me. Was all of my instructors had been in the field of manufacturing in some way, shape, or form, and they didn't just talk about the technologies or talk about what we were learning. They could give you real world experience and talk about that and give you examples of how these things came about. That was, it wasn't just, well, I read this in a book and this, is supposed to work because, the formulas work out. They'd been out in the field. They understood how materials work in the real world and how changing speeds and things like that do impact the part, material flow, etc. And that's something that I agree we've really lost on a lot of those things. As far as technology for your company and hybrid, do you feel that there's an opportunity here to take this to the masses?
Absolutely. Our business has been really developing the process, and we've specifically aimed at research over the last number of years, because we needed to understand what we had, what we developed. We partner with a number of people to test our technology and to help us improve it. We reached a point this year where we started to produce production systems into production, and we've made a number of sales into those areas, and we're actually starting to use the technology to make a difference to real parts. The problem at the moment is, and it goes back to the design guys, is that we're looking around for existing components that lend themselves to the hybrid approach. What will happen over the next several years is that people will start to design for hybrid because the tools are now available. And you will see a switch from components that could be made both additively or subtractively to parts that can only be made in a hybrid way or in an additive way. And then it will become a more mainstream process, and designers will design for it. The infrastructure that supports production, the machine tools, the systems, the supply of raw materials, the CAD and the CAM, and all the other tools that are required to make this technology work, will all become more robust and more available and more affordable. And at that point, we'll see a step change, I think, in the way we manufacture parts.
That's tremendous. Pete, we're out of time. We've been here today with Pete Coates, co-founder of Hybrid Manufacturing. This has been the Destiny of Manufacturing podcast, and we'd like to thank our sponsors, the Precision Metal Forming Association and the PMA's Educational Foundation. Thank you, everybody. Have a great day.